Let us look at probability problems involving people. You and I. We are people who could be watching this video at the same time. Or maybe not. Is there a way to tell how likely either possibility is?
But our behavior could be different. I mean, I am awake in the morning, but you are nocturnal.
But what if without accounting for behavior we could figure out the math behind it?
Is that possible?
Sure, let us look at an example. Ajay and Adya are friends. What is the probability that both will have the same birthday? There are 365 days in a year, a non-leap year. If Ajay's birthday is on one day, let us say January 1, then Adya would have to have her birthday on the same day, January 1. So, if my total number of outcomes is 365, my favorable outcomes would be 1, January 1 in this case. You could choose any other day. So, probability that Ajay and Adya have the same birthday would be favorable outcomes divided by total possible outcomes, or 1 by 365.
But what if Adya has her birthday on 20th May?
Then Ajay would have to have his birthday on 20th May as well. It would still be one day out of the 365 days of the year. Let us look at another problem. In a group of 3 students, the probability of 2 students not having the same birthday is 0.992. What is the probability that the 2 students have the same birthday? There are only 2 possibilities here. Either 2 students don't have the same birthday or 2 students have the same birthday.
But there are 3 students.
But we are only talking about 2 of them at a time.
Wow, math is cheating with English's help now.
Now recall that total probability is equal to 1. So probability of 2 students not having the same birthday plus probability of 2 students having the same birthday would be equal to 1. Or 0.992 plus probability of 2 students having the same birthday would be 1. In other words, probability of 2 students having the same birthday would be 1 minus 0.992 or 0.008.
Okay, what if we were given the probability of 3 students having the same birthday?
We would solve it similarly. Either they would have birthday on the same day or they won't.
Oh, I keep unnecessarily complicating it in my head. Thanks.
Let us look at another problem. 2 customers are visiting a particular shop in the same week, from Monday to Saturday. Each is equally likely to visit the shop on any day as on another day. What is the probability that both will visit the shop on consecutive days? Let us chart out the days customer 1 would go to the shop. Since my week is counting from Monday till Saturday, we list out the 6 days. For each case, customer 2 could go to the shop on any of the 6 days. So, if customer 1 is going to the shop on Monday, customer 2 could go on any of the days from Monday till Saturday. So, for customer 2, let us write down all the 6 days. However, only Tuesday would count as a consecutive day. So, if customer 1 goes on Monday, then customer 2 going on Tuesday would count as a consecutive day. Let us see what happens if the customer 1 goes on Tuesday. Now, customer 2 could go on any of the 6 days. But in this case, Monday and Wednesday would count as consecutive days. So, if customer 2 goes on Monday and customer 1 goes on Tuesday, that is a favorable outcome. Or if customer 1 goes on Tuesday and customer 2 goes on Wednesday, that's another favorable outcome. Similarly for Wednesday, if customer 1 goes on Wednesday, then customer 2 going on Tuesday or Thursday would count as favorable outcomes. For Thursday, Wednesday and Friday would count as consecutive days. For Friday, Thursday and Saturday would count as consecutive days. However, for Saturday, there is only one case, Friday, which would count as a favorable outcome. Now, what is the total number of outcomes here? This is very similar to a dice problem. There are 6 faces on one die and 6 faces on another die. But when both outcomes are looked at together, then 6 multiplied by 6 gives me 36 outcomes. Similarly, here, there are 6 days for customer 1 and 6 days for customer 2. So 6 multiplied by 6 is equal to 36 is my total number of outcomes. Now let us count the number of favorable outcomes here. We would have 10 number of favorable outcomes. So the probability that the 2 customers go on consecutive days would be equal to favorable outcomes divided by total outcomes, which is equal to 10 by 36 or 5 by 18.
Phew, that was some problem.
Very similar to the 2 dice problem, don't you think?
Oh yeah, that hadn't occurred to me.
Why don't you try a problem on your own? In a musical chair game, 5 people go around 4 chairs. The music could play for up to 2 minutes once it starts playing. What is the probability that the music will stop within the first half minute after starting?
Wait, this is not a problem on people. It looks similar to areas.
That is an interesting thought, Ayush. How?
We could measure this on a time scale. So the first 30 seconds are favorable and the total 2 minutes are my total number of outcomes, or 120 seconds is my total number of outcomes.
I must admit, that is correct. Go ahead and try other problems from your textbook. If you need more help, check out the question bank.
Oh yes, now I know I can ask you if I'm stuck. Thanks, Miss Howard.